Hello, everyone, and thank you for joining us for today's Coringo Tech Tuesday webinar. This session's topic is Evaluating Object Storage Solutions for 2020. I'm John Bell, Senior Consultant at Coringo. For today's webinar, I'll be your host, and our subject matter experts will be Ryan Meek, Principal Solutions Architect, and Jose Gonzalez, Sales Engineer. Ryan and Jose will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have several resources available by the Attachments and Links tab on your view screen. If you have any questions after the webinar, you can always reach us by email at info@coringo.com. Just some quick introductions here. I'll start off first. Again, I'm John Bell. I've been with Coringo for 8 years, and I'm a senior consultant based in Austin, Texas. I specialize in the design, implementation, and management of object storage. I've worked with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions. Ryan, why don't you kick off next and go ahead and introduce yourself?
Hi, everyone. I am Ryan Meek, Principal Solutions Architect at Coringo. I joined the company in 2006 as a developer, and I've had roles in development, product management, and sales. So really looking forward to getting into evaluating object storage with you. Jose, would you like to introduce yourself as well?
Yeah, absolutely. Hello, everyone. Yeah, I've been with Coringo since 2015. I'm originally from Spain, but I live in Canada now. I work with customers here in Canada, as well as in Latin America and the US. My role in Coringo is to assist customers by architecting effective storage solutions, as well as answering technical questions and providing assistance during product evaluations. I also work with partners to integrate their solutions with Coringo Swarm.
Very good. Thank you, Jose. All right, before we dive into the nitty-gritty of things, let's do a quick about Coringo first. So Coringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Coringo's flagship product, Swarm, decouples data from applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Coringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Labs, UK Science and Technology Facilities Council Scientific Computing Department, or SCD, Texas Tech University, US Department of Defense, the Brazilian Federal Court System, British Telecom, and hundreds more worldwide. Okay, Ryan and Jose, I'm going to hand the reins over to you.
Thanks, John. Great. Welcome again, everyone, and looking forward to getting into our topic for today with you on evaluating object storage. So you have an interest in object storage. You are looking over the space. What are the major considerations? What do you need to know? Broadly, the build or buy decisions, storage data management features, interfaces, unified namespaces, metadata, and support, and the organizations that you're dealing with. How can you list those features, keep track of those features, and how can you use kind of a knowledge of the overall sector for your benefit? So first thing that you really want to be aware of here is sort of the build or buy decision. Do you want to buy bricks that are pre-configured and pre-integrated as hardware and software, many times presumably with one organization that backs them? Or do you want to take a much more software-defined approach where you'll actually take on the integration yourself? the appliance mechanism is hardware, software. Software defined is generally just software and doing your own integration. Maybe Jose, could you talk a little bit about the kind of appliance versus software defined choices and how you see people going about those really successfully?
Yeah, for sure. So yeah, I believe there are trade-offs between these two models. Yeah, on one hand, with the appliance model, you have essentially a turnkey solution. Just basically you have a part number or a SKU when you're ordering your brand new object storage cluster, right? So, and you just need to put, 10, 20 servers together, on this case, appliances that came pre-configured for you. So you have kind of limited possibilities there because you are kind of, close to a specific solution that comes pre-built for you, right? So there is no way that you can say, oh, I want to use these specific these drives or this specific brand of servers because I trust them, right? Or for any other reasons. On the other hand, you have the software-defined approach, which is more like build whatever you really need to build, right? For instance, we have seen in the field that many customers have very different requirements in respect to the object storage that they want to build. They might have a requirement whereby they are storing data for 10 years or something like that. So it's kind of deep archive solution. So what they are going to need there is very high dense servers, so meaning servers that can hold 45, 60 drives per server, so they can go, up to petabytes in size quite easily. Also, you may have a use case where you need kind of throughput. For instance, if you are a media and entertainment company and you are dealing with video streaming, right? So on that case, you will need more CPU cores and less these drives per server. So basically what you're looking at is to have a ratio that is probably one CPU core per 2 disk drives on the system, something like that. So in the end, you are building the system quite differently. You are going with maybe 12, 16 drives per server instead of the 60 that you are going with this archive. So all of these, assumptions or requirements that you have to have, I think they are the actual driven factor that will, help you to build a system.
So it sounds like the major difference is software defined is much more flexible, presumably at the expense of time, and hours of your workforce. What are some of the advantages of the appliance model? I mean, who may be the right person for the appliance model?
Yeah, so basically, probably 90% of the people will be happy with the appliance model because kind of a generic appliance that hits, like I said, 90% of the use cases will be fine for you. So it will simplify, the building process of your cluster. And like I said, in the end, you only need to order a number of quantity on a specific SKU or reference, right? And that's pretty much it, right? So I believe that's the point for the appliance model. With the software defined, I just wanted to point that even though you have this kind of flexibility and you may have like 1,000 questions about how do I put together this kind of cluster based on software, right? What servers should I buy for this specific purpose? Oftentimes, the companies, the vendors that basically sell object storage solutions, so will provide you assistance on defining and on building that specific cluster that meets your needs. And we will talk a little bit more, I believe, at the end of the presentation about it. but something to keep in mind.
I mean, yeah, I get your point there. We certainly at Caringo, our product is available software defined, and we are always available for meeting customer requirements in flexible ways. I would say here too, I think one of the other advantages of the software defined model is just being able to arrive at sort of exactly the right tuned solution for a use case. You know, sometimes it really matters if you need to hit, you know, exactly the right amount of latency or the right, you know, user experience behind, say, photos or videos loading, or exactly the right price point.
Yeah, and also the thing is about the appliance model versus the software defined is, well, in the appliance model, you basically need to buy another appliance if you want to, you know, increase your capacity on the cluster. And that might be that you are buying like 400 terabytes at once because the appliance is so dense, right? So with the software defined, there's somewhat more flexibility when you are, you know, purchasing more capacity for your cluster. So it's, yeah, more flexible on the license as well.
Well, that's a good point about capacity on demand. I mean, that's probably something that you need to consider up front. I mean, how much flexibility do you want in adding capacity? Do you want to be able to add capacity at runtime? And what does the storage system support with respect to adding capacity at runtime?
Yeah, for sure. And the thing is, when you think about this kind of storage management features, you need to address, obviously, these kind of questions about how do I going to grow my cluster, right? Also there is not always about increasing capacity. So it's also about how do I manage the system and what kind of features the cluster provides me to manage the system. For instance, is the cluster able to, you know, rebuild itself in case you have a broken disk, right? Or going back to that increasing capacity topic, if I want to add a server into my cluster, do I need to go through the process of kind of provisioning that space into my cluster, or it's something that is kind of automatic? Let's say that the cluster recognizes that there's a new server in the cluster, and it just automatically balance the cluster across. So it basically starts to fill out that server with data, so you get more redundancy and you get more performance out of the cluster. So this kind of things happen. Yeah, go ahead. Sorry.
Wouldn't you say there's quite a bit of difference in the ease of use of adding a new node to a cluster? I mean, I've heard stories about, you know, pages of manual command line interactions as opposed to much more automatic. Can you say a few things about that?
Yeah, for sure. So the thing is, well, it comes to what is the type of architecture that the cluster has itself, how it's built, you know, internally, let's say. So depending on how it's built, you might need to actually format the disk drives with a Linux file system or something like that before presenting those drives to the cluster. Or you might need to take into consideration where exactly I am going to put this server into, meaning that the cluster is not a flat space. So it's about the ring architecture and the mesh architecture. There are two models of the storage cluster architecture. These two basically, so we have the mesh architecture where all nodes perform all functions, and you can just you know, grow and increase your capacity by connecting a new server into the cluster, and the system will recognize that new server. So that would be the mesh architecture. That's what we have in Swarm. And the other architecture is ring architecture. So when you are increasing capacity, when you are adding a node into the cluster, you have like rings, like subclusters, let's say, that takes care of different data protection schemes. So if you're adding a new node into the cluster, you have to think, or should I put it for this ring that takes care of for two-erasure coding data protection, or should I put it on this other ring that is for full replicas only? So that's the kind of things that, basically, you have to address by just first thinking about what is more important to me. I need to have this tight control or where I put in my data on. Some people actually need that kind of knowing where my data is at any time within which specific server, in which specific drives, and that the data is not going to go anywhere else that only that point. Or some people just need to be as simple as possible when they increase the capacity of the cluster. So it's in the end, it's just about connecting the node to the cluster and let the cluster do the job. So I think all of this is quite interesting, and I know that I touched a lot of points there. But in the end,
I would say, let me just ask you a question here then. So would you say then ring architectures, I would say for a user evaluating object storage, to be aware of if the object storage system is a ring system or a mesh system, and be aware that I would say ring systems incur additional costs really in adding nodes. Would you say that's a fair statement?
Yeah, management costs, exactly. So it's just about time. It's just also there's an impact on performance. If you have a mesh architecture, basically all the nodes are responding to the request. So all the storage nodes are basically serving the request that the client is asking for. For instance, I want to get this 200 gigabyte file, right? So all the nodes will be basically pushing that 200 gigabyte files to the client, whereby if you are on a ring architecture, only the specific servers from the ring that has that file will be pushing the data. So it's a very different architecture, so it has some trade-offs. But yeah.
Okay. And so as far as storage management features go then, in general, there's the architectural considerations, the ring versus the mesh. I would say too, then, as far as automated failover and recovery go, I would say that the main thing to verify is it really automated failover and recovery, right? Because haven't we seen instances where it's actually not automated failover? I mean, how do they expect this to happen when someone isn't looking at it or in the data center?
Yeah, precisely. It goes back to what I said about having the cluster, be able to recover when a failure happens, right, by itself, and not expect that administrator will log into the system and click on rebuild or click on failover, whatever.
Strong recommendation. Strong recommendation. Make sure failover is automated and recovery is automated, right?
And also the ability when you are recovering data, it's very important that all the nodes perform that recovery or make that recovery effort for you. Meaning that if you have many broken disks or even just a broken disk on the system, if you have the ability, if your cluster has the ability to that all the nodes participate in the recovery effort, that will be really, really fast to recover. So if you compare to RAID or anything that is limited to a number of drives, being able to recover a full 12 terabytes, 14 terabyte disk drive, well, you will be impressed how fast these nodes or object storage nodes will be able to recover data. So just keep that in mind that you don't need to rebuild these drives. What you have to rebuild is data, and also all the nodes should participate in that recovery effort, so it will be really, really fast. So and you will get again back your capacity on the cluster.
Yeah, I mean, I think the key takeaway there is just be very aware if your system is relying on hierarchical legacy file systems plus RAID, you're probably on the wrong path, because the quality of service on that server or on that node will be, degraded, and that server is vulnerable to additional failures in a way that true object storage isn't.
Yeah, and just to close this topic, maybe we can talk a little bit about volume portability. So that's the ability to basically, at some point, just get one disk drive from one server and put it in a different server in the cluster and have the data recognized like, nothing happened. So this is kind of interesting. If you, for instance, have a faulty motherboard, faulty processor, or something like that on the server, but your data is fine because the disk files are okay. Actually, if you have or the cluster has this feature of volume portability, you will be able to just take out your disk drives from that faulty servers and put it in other servers in the cluster. So, and the data will be recognized automatically. So actually, there's no need to rebuild the entire server into a happy part of the cluster. Just moving actually physically moving the disk drives to different servers on the cluster.
Yeah, so I mean, presumably those different those drives, they contain replicas and they contain erasure coding segments, and so those replicas and segments are valid no matter what server is hosting those volumes. It's another kind of advantage of a pure object storage architecture versus someone that's putting together a legacy file system in combination with RAID, wouldn't you say?
Yeah, precisely. Also going back to the RAIN and mesh architecture, something to keep in mind that is on the exercise is the protection schemes, right? So we just talk a little bit about that, but you have to take into consideration that you should be able to set any kind of protection scheme that you want on the logical level, meaning that it doesn't matter, how many servers you have on a specific ring or anything like that, or having a specific ring for a specific, data protection scheme. If you're able to set the protection scheme that you want on per endpoint basis or per packet basis, that would be great for you. So you have kind of very multi-tenant environment, right? You may have a massive petabyte size cluster with a number of endpoints and have different protection schemes for different endpoints because they are used for different purposes. You may want to have kind of 10-2 erasure coding, for instance, to save a space for cold data that you have to store in your cluster. But at the same time, and on the same cluster, you may want to have, something that is quite, hot, let's say. So then you go with something like 4-2 erasure coding, 5-2 erasure coding, something like that, right? So it will be faster to respond to those requests. But you have the ability to make some every single protection scheme on the same pool of resources on the same hardware. I think that's interesting.
And I think what you're getting into there also, it brings up the idea of a truly multi-tenant, a multi-tenant system that can not only offer different data protection strategies, but can apply different identity management systems to different parts of the namespace. You may have just different identification systems that apply to different sets of users, and can the system you're evaluating incorporate that, and can the system delegate control to, say, different departments or different users? Can you talk a little bit just in general about the other considerations in access control of the content in multi-tenancy and identity management integration?
Yeah, so for sure. So first of all, you have to have some kind of integration between an identity management server and your object storage. Basically, because if you have 1,000 users and you have to create 1,000 accounts, individual accounts into the object storage system, that would be, kind of a mess and a long work to do there. Sounds
like a nightmare.
Yeah, sounds like a nightmare, exactly. So yeah, having this identity management integration, I think, is key for you, especially if you are dealing with, I don't know, even with 10 users and a couple of groups, just that. Also, on that regard, on the regard of multi-tenancy, the ability to do chargebacks and to control the quotas or setting quotas by buckets in terms of how much bandwidth I will be allowing for this specific bucket, or the same goes for capacity. I want to set a quota that after 10 gigabytes, it automatically sends an email that basically notifies the user that is reaching his quota, right? So that's something that is part of the multi-tenancy features, as well as the flexible protection schemes that we talked a little bit about before, and that identity management for access control, setting permissions and stuff like that.
So Jose and Ryan, we actually have a question from the audience regarding that regard. And the question is, when we talk about identity management integration, what capabilities or pieces of the identity management stores are typically used with an object storage solution? What are they referencing in the IDM?
So yeah, users and groups are usually what you are basically referencing from the IDM. So you are setting up permissions that set, for instance, this specific group of users that comes from the alt app, Active Directory, whatever, will be able to download and upload, but not to delete anything, for instance. That would be an action, as you can say it. So I think that's where the IDM could be referenced to. And you
it's basically just a reference to definitions of users and groups. It's not setting policy itself, right? The policy engine resides within the object store itself. Is that what we're getting at?
Yeah, that's right. So there is a communication that can be encrypted via SSL between the cluster, the object storage cluster, and the IDM. So all the communication is encrypted and is tied. So if a user logins, it will be using its own password, right, to log into the system, the one that it uses for anything else that is, in your company, in your service.
What about access with tokens?
Oh yeah, for sure. So yeah, that's something that is interesting as well. It's the ability to have tokens instead of just username and passwords, right? Something that a token is basically something that expires as well. So you have kind of a specific access key and a secret key to access the system, and after a specific amount of time, if you want to, it can be expired. So you have to renew your token. So it's something that, yeah, for sure, it will be very, very handy when you're especially dealing with, access over S3, or if you are dealing with providing access to a third-party company and you don't want to create a user for them or something like that.
So it sounds like not just integration with identity management, but a good object storage solution is going to provide methods for you or end users themselves to do management of their tokens as well.
Yeah. Yeah. So yeah, there is another thing that I want to discuss is the compliance features that we have or that you should have on your cluster, on your object storage cluster, right? So we talk about the protection schemes, we touch a little bit about multi-tenancy features, but also there is the compliance ones that you also probably need to look at. We are talking about WORM, we're talking about integrity seals. So WORM is wide ones with many. So it's kind of a way to also to kind of log the information to prevent that information is deleted from the cluster after a specific set of time. Let's say this information cannot be modified or deleted until February 2025 or something like that, right? And integrity seals is also a way to verify that the information has not been tampered with. So let's say that someone modifies that file, that object that is stored in the cluster, how do I prove that information has been modified or has not been modified, right? So that's where the integrity features like integrity takes place there.
Yeah. So what verticals and what would apply most directly for the compliance feature set, would you say?
Well, basically federal or any kind of, justice departments or, court of law, all these kind of type of scenarios will for sure require some compliance features.
Yeah, I think in our sort of direct experience dealing with courts, appellate courts, also financial services come to mind, check images, just anything where you really want to ensure that the object is exactly the object that arrived when it was stored. I think these will all be use cases where the write once, read many features and object integrity verification features will really come into play. I wanted to move us forward too, especially because you brought up S3 and token access as a mechanism. I know S3 has become I would say it's probably the most popular protocol for object storage. It's been implemented by a number of vendors. In our case, we always had a RESTful API. So in our case, it was a matter of adapting it a bit for S3. And so we ended up with a highly performant implementation of S3 as a protocol. I don't imagine that a lot of the legacy or more, file system and RAID oriented storage systems had such a clean S3 implementation on top of a traditional file system. Is there anything more to say about that, just in general? Like what does a user really need to know when evaluating the S3 if a object storage system has an S3 implementation? What else do they really need to check and be aware of there?
Yeah, I just believe that if I am just buying a new system, right? So now that I have my petabyte size cluster, I know what features I need. The question could be, how do I plan to access it, right? Which protocols do I need? It depends basically on the applications, and it depends on my workflows that I need to support on the cluster. So basically, you have the object approach, which is native HTTP or native API, RESTful API, S3, as Ryan said. And also there is, they might need some NAS or file access to the object store, right? So file access, it's kind of a different approach in the object store world because, well, you have an object store system. It's not a NAS, okay? So just keep that in mind. So there has to be some kind of translator in between, or a proxy, or something that basically speaks NFS, for instance, for your clients or for applications. But in the backend, is basically speaking any object protocol like HTTP or S3, right? So I think from your perspective, when you're buying a system, it's just something that you have to keep in mind. What kind of access do I need? What are the requirements that we have for it, and what are the workflows that we want to support?
I would say here too, a really major consideration to recognize is whether this is multi-protocol support and multi-protocol access to the same namespace and to the same files, right? Because sometimes you may end up with a namespace that's actually not accessible through the other protocols, and you don't want that to be a surprise, right? You want to know that up front.
Yeah, I think that's the next slide actually, so we can just take the opportunity to look a little bit about namespace.
Here we go.
You got it. So yeah, exactly that. Like Ryan was saying, it's basically if you have this kind of requirement whereby you have many protocols that you need to implement in the system, just bear in mind that it might not go to the exact same namespace. So sometimes if you are accessing via NFS, it's stored in a way that is not readable if you access the same, or if you try to access the same information over S3, right? So just keep in mind that you should have access to the exact same namespace. It doesn't matter what kind of protocol do you use to do that, right? If I have a bucket on my object storage system, I upload a bunch of files over NFS, I should be able to see the exact same names and the exact same files over S3 if I open the connection, using any S3 client applications there. So I think it's really important
hold on.
to have a unified. Yeah.
Hold on here though. So wait. So really, object systems are generally flat namespaces, right? So, I mean, are we always considering a slash a delimiter into a hierarchy, or how do systems usually consider that?
Yeah, precisely. So that's something that basically, if you have an object storage, it's a flat namespace. Once you reach the bucket level, it doesn't matter how many slashes you put on your file name, right? So the system will store that as a name for you. The thing with you're dealing with NAS or NFS, SMB type of protocols is that you have to have the ability to, when you are writing data and you're basically drag and drop a folder into a exported bucket over NFS, for instance, right? So it's important that that information is stored in a way that is readable for both sides. So for sure, if you go with the S2 client, you will see kind of a folder. The same goes if you go over SMB or NFS. You should see kind of a folder instead there, but know that in the way that it's stored on the object storage, it's basically a flat, the slashes. So it's a unique name there stored on the cluster.
So you brought up access to the metadata in the different protocols as well. That can be pretty tricky, right? I mean, metadata on an NFS file or a file that was put in through NFS, it can be kind of tricky to access that, right? Is that, I know in our case, we put in special hooks so that metadata would be available to an NFS client. What would you say a user should really look for with metadata features across the general object storage landscape?
Yeah, so the ability to include some specific user metadata when you upload the file into the object store, I think that's key, especially if you are dealing with billions of files within the same cluster there. So the ability to retrieve or to find a specific file among kind of billion files by just looking for a specific project number or client name or something like that. I think that's really, really important, right? So and have that.
Yeah, I mean, I would just note. I would note there too. I mean, at Caringo we use Elasticsearch, which is great for scalability and speed accessing metadata. I would say in general too, the systems I've seen that are the biggest disasters generally try to use or have tried to use something like a relational database for the metadata, and they just run into scaling issues. So I would say here, be really clear what the metadata facility is, right, in an object storage system that you're looking at, and how it's going to scale, whether the only way that it will scale will be vertically, like getting a larger and larger node or larger and larger server, or whether it
Mm-hmm.
can scale, horizontally. I mean,
Yeah.
what else would you say there is important for a user to look at?
I think the most important thing is that you have to protect your metadata the same way that you want to protect your data, right? So it should be basically encapsulated. The metadata should be encapsulated with the file itself. And when you are protecting that object, you are protecting not only your file, your data, but also the metadata that comes with it, right? I think that's key. If you have, a bunch of files in your system and the metadata is somewhere else, Cassandra database, or in a specific region of another file system or whatever, if you lose that metadata store, you're basically doomed. So you won't be able to retrieve anything.
You're pretty dead in the water if you can't find metadata about your files. You only have
even if you have your file there, you won't be able to retrieve it because there is no metadata, so there is no way to know which file that you want to try to point try to download it from the object store. So I think it's key to have that ability to encapsulate the data and the metadata within the object itself and protect that object on the same way. So, I mean, when you are using 4.2-ish or coding, or if you are using 3 replicas, you are doing 3 replicas of the data of the file, but also the metadata that comes with it has the same level of protection. So I really think that is key for, the ability to do that.
Yeah, there's a note here about collections. Can you explain a little more about what collections are? Sort of, I can tell you in a Caringo context, since we do use Elasticsearch, we can use something called a collection as a saved query, and it's a lot like a smart folder. Can you talk a little bit about how extensive that might be in object storage in general, or are there any other systems that actually provide that?
Yeah, so it's going back to what I said before about trying to find all the files that belong to a specific project number, right, or to a specific client. Well, collections is basically the ability to do that in a way that it doesn't require a lot of resources to keep that information, right? For instance, if I want to just get this information, I should be able to get all the list of all my files that belong to a specific project in a matter of milliseconds almost, right? And not just wait like 5 minutes or even a day to get a list, especially if you are dealing with very large clusters or with billions of files on it. So the ability to have, in this case, well, in our case, it's Elasticsearch that provides that index capabilities. I think is really, really important there.
I think the key takeaway there too for someone evaluating is, really know exactly what the metadata system is and, understand how it scales, and don't be surprised, right?
And how,
if you do get surprised, go ahead.
Yeah, and how the metadata is protected, right? That's the other thing that you should ask about it.
Exactly. And if you do get surprised, that might be a good lead-in to support and other concerns. Right. So I think the biggest one is commercial versus do-it-yourself and open source. That there are open source approaches out there to object storage. I don't know. Do you want to say, Jose? Can you explain a little bit about some of the open source options and how that kind of aligns with commercial versus do-it-yourself?
Yeah, so obviously it's great that open source is in the world. I am truly a lover of open source software. But the thing is, on an enterprise class system, you will need some knowledge to be able to put together a system that is based on open source. Basically, the do-it-yourself part is kind of heavy on this kind of systems, right? So you will have to read a lot of documentation. You will have to ask a lot of questions of forums and stuff like that. And the same goes when you are maintaining or the system once it's up and running. So it's again effort that you have to put in. So some companies, some organizations rely on open source because they have a very good IT or team there, and very familiar with these kind of solutions, and they are happy with them. That's an interesting way of doing things. The other way will be relying on professional services from the vendor that is basically providing you the object storage solution. The trade-off there is basically that it will help. They will help you to first to build a system to architect the solution based on your needs without having you to read 1,000 pages of documentation and asking questions on forums, right? The other thing is, well, when you are installing or deploying the system, if you have to do it yourself, again, it's time that you have to take into account, and the same goes with support, with professional services, installations, deployments, and support. I think it's easy way to do that. It doesn't cost too much, to be honest, and it saves you a lot of headaches sometimes. But again, it depends on the kind of type of the purpose or the type of the company and the knowledge that you have there.
Mm-hmm. Yeah, I mean, it's interesting talking about open source and do it yourself. I mean, in a way, we're all huge fans of open source. We all love Linux, and the world's a better place with it. So it's not to say there's anything wrong with open source. It's just sometimes it's not the right tool for the job. And I had a friend whose name I won't mention here, but he said he used to laugh and he used to say, open source is only free if your time is worthless. And I think just what he meant by that was, in the case of Coringo, we put a lot of effort into configuring open source software and distributing open source software in a way that's exactly right for object storage. So I think there is a premium and there is a value there, and so not to say that do-it-yourself isn't a good approach and that there aren't places where it makes sense, but from a Coringo perspective, we put a great deal of effort into packaging exactly the right open source and exactly the right way to support Swarm as an application for real world scenarios.
And I would add, Ryan and Jose, it's good to realize that the difference between having a generic body of knowledge when it comes to thinking about doing it yourself versus working with a vendor such as ourselves, Coringo. We've been doing this for 14 years, nothing but object storage. And we've been doing it a long time. We've been doing it for thousands of customers. And when it comes to commercial versus do-it-yourself, this goes all the way back to the very beginning about build versus buy. Being able to take advantage of a vendor like ourselves that has that deep specialized knowledge in object storage is definitely something you want to take into consideration when you're evaluating what type of object storage solution you want to go with. Does that object storage solution come with that deep specialized body of knowledge that's readily available for you to take advantage of, or are you going to have to kind of Google your way through things and hope that everything works out for the best? That's something to bear in mind when you're evaluating the solutions that are available in the marketplace.
Absolutely.
Yeah, for sure.
I think that's a very good point, John. And I think that takes us to it. I did see a question that came in from the audience. Can you provide some real world information about what type of data is best suited for object storage and what data is not? Structured, unstructured, VM, data stores, etc. Thanks. Who wants to take that, gentlemen?
Okay, I will. So yeah, basically, object storage is for unstructured data. It means like images, video, PDF files, or any files that basically doesn't change a lot. It's not suitable for structured data like databases, for instance, because every time that you do an insert into the database, it will become a different object in the cluster. So it's not very efficient, to say the least. So if you want to have high performance, there for your database, you will be looking at, some sort of SAN solution with SSDs or, solid state drives on the system. So that's where the SAN architecture shine when you're dealing with structured data. But yeah, I think that's object storage as an archival solution most of the time. It's used for archival purposes and to store massive amounts of data.
And just to add a little color to that, you mentioned VM data stores. To Jose's point, there are going to be there's a lot of things that goes on in a virtual machine hosting solution. There are the images where there are pointers open in a block-based target all the time, and that's an active image. But there are also backups, and an active virtual machine image is not necessarily a good use case for an object storage solution, but moving snapshots and backups and things of that nature, you can use object storage for that kind of use case, because it's not something that's being walked through with a pointer all the time and constantly changing on a block level. It's a snapshot, it's solid, and being able to offload that space usage off of your virtual machine hosting solution and then saving the high-speed disk for active images, it can be a big win for you. Mm-hmm. So it's a matter of it's a matter of picking your battles when it comes to doing the evaluation. Not just in object storage solutions in general, but evaluating the use case, whether it's structured or unstructured. Which pieces can I treat as unstructured, and can I offload to a cheap and deep object tier, and so on. Yeah,
that's right. I think the takeaway is if your data is kind of not being modified a lot, that's perfect for object storage. If you have hot data like databases or even VM disk images, you should use a SAN solution there for your needs.
All right, very good. Well, I believe that's all the questions we have for the day. So thank you very much, Ryan and Jose, for your presentation today. Excellent stuff, as always. And thank you, everyone online, for joining us today. To keep up with Caringo, feel free to follow us on Twitter, LinkedIn, or Facebook. And if you do have additional questions or would like to schedule a custom demo, please feel free to email us at info@caringo.com. And I'd also like to take this opportunity to invite you to our Tech Tuesday for the month of January, on January 21st of 2020, where our topic will be object storage for advanced users. And we're looking forward to seeing all of you there. That said, thank you again, everyone. We're going to go ahead and close down the webinar, and we hope you all have a great day.
Thanks, everyone.